Step 1. Our hypothesis is that 59% of MFL Marmac students have an Xbox 360. To come up with our sample size, we had to use this formula. N equals Z score divided by Z P hat Q hat all over E squared using a 0.95 confidence level. 1.96 squared times 0.59 times 0.41 divided by 0.05 squared will equal 372 students. Due to the limit students, we took a fourth of this number and surveyed 93 people. To get our 93 people, we randomly choose advisories in our school and asked them if they had an Xbox 360 or not. Then we tallied how many said yes and how many said no.
Our claim is 59% of students at MFL Marmac own an Xbox 360. P equals 59% claim. Our no P equals 0.59 and H1 P does not equal 0.59, which is our alternative. In order to know if our claim is right, we have to use a two-side test. It's known as a two-tailed test, which is shown there as 0.025 on the left, which is negative 1.645, and the same is on the right with a 1.645 positive, which leaves us with 0.95 as our critical level.
To do our formal hypothesis testing, we have to use this equation. Z equals P hat minus P divided by the square root of P minus Q divided by N. In our problem, P hat is 0.43, P equals 0.59, Q equals 0.41, and N equals 93. So if you put that into the equation, Z is going to equal 0.43 minus 0.59 divided by the square root of 0.59 times 0.41 divided by 93, and that equals negative 3.14. So as shown in our graph, we had to place that, and it falls on the left-hand side of negative 1.645, so it is not in our critical region.
Our final claim after we placed the point on the graph, it was outside of our critical region. So evidence shows that the null hypothesis is rejected and also shows that our claim is not supported.